Thomas, thank you very much for the introduction and thank you for the invitation to present at this Eurodairy webinar. I am Niels Bastian Christensen, a consultant at Sikkes Livestock Innovation here in Aarhus, Denmark. My presentation is on CompactTMR with the title CompactTMR for Improved Feed Efficiency. I will take you through some slides here with the following outline. I will define the CompactTMR concept. We will look into the CompactTMR mixing process. And I will go through important steps on monitoring feed mixers and adjustment of feed mixers to the CompactTMR challenge. We will have a look at feed bunk management. That is a very important part of the CompactTMR concept, and how to monitor the behavior of your cows as part of the feed bunk management. And finally, we will look at some of the effects of CompactTMR on dairy production with special reference to Danish data. The CompactTMR concept is based on studies on rumen function out of Aarhus University that we have been undertaking for years. The introduction of the concept and development of the concept together with Danish farmers started in 2012. There's two really important aspects of this concept. Overall, we want to ensure that all the cows in the herd are fed the planned ration 24/7. And to accomplish that, we have these two criteria, and one is that there should always be feed in the feed bunk. And that will mean that there will always be leftovers. The minimum amount is, as a guideline, 2%, approximately 1 kilo per cow per day. And the second part is then that the mix is really mixed so well that there could be no sorting by the cows, so there could be no change in the composition of the mix during the day, and also that this uniform mix will ensure that the cows don't spend too much time at the feed bunk sorting, but they just go to the feed bunk to eat. When you look into the requirement to the mix to accomplish these goals, then the starting point in Denmark would typically be a combination of grass and maize silage in the TMR or in the PMR with automatic milking system. And with grass in the mix, we always consider the grass part as the skeleton of the mix. And that means that we actually aim to put every other ingredient on this grass skeleton. So when the cow is eating on this mix, she will meet this physical structure that is the grass, and everything else will come with it when she starts to eat on it. One consequence of this focus on the skeleton of the mix is that we would like to utilize all the fibrous feedstuffs that is in the mix to carry the other nutrients. So that will also mean that we don't want to see any chunks of balls of grass running along the feed bunk, but we will see that they have been completely mixed up into a homogeneous mix carrying the other nutrients. There is some impact of chop length of your silage related to this aspect and also how easy it is to mix a CompactTMR, but that would be for discussion another day. When we look at the mix, we would like to see that pretty much all other ingredients has disappeared. When you take a look at this picture over here, that would be a typical situation, maybe with 25%, 30%, between 25 and 30% grass dry matter out of that mix, and it's pretty much all looks like grass. The other commodities, concentrate, corn, silage, whatever, has kind of disappeared. And also when we when we look at this mix, and especially when we go through this mix and look at the floor underneath, it should be clean. So the mix should be able to retain all the small particles. We don't want to have any pellets that actually survives the mixing process, but if they do, they should still be kept in the mix. To accomplish this, we need to add moisture, and we need to run a mix with a relatively low dry matter in order to enable the mix to keep all the small particles. And finally, we want to cut the silage so well, and we want to mix it so hard that we end up with a very homogeneous structure and having a relatively short skeleton. The standard protocol for mixing CompactTMR was actually developed in 2012, and we have been kind of forced to stick to it ever since, because this is actually the protocol that is working. We have split the mixing into 3 different phases. We have the first phase where we soak the dry components, the phase 2 where we are mixing the concentrate part with the fibrous part, and then the final phase of a typical ration when we mix in the corn silage. The first phase here is what is the soaking phase, where we, as I just said, we will load the commodities, all the dry feedstuffs, if there is a concentrate, whatever in it, and then we will add water. When we are adding the water, we will have to run the mixer, and then we will let it soak. The minimum is about an hour, but the typical way to do this would be to leave the mixer overnight, because it's not used anyway, and it can do have a, you can say, a positive effect on the mix by let the ingredients soak. Important about adding water to TMR is to add enough water. It's very dangerous to add too little water. I will show you some data in a minute, but if you add too little water, you risk that your soaking mix will make a kind of a dough that is very hard to mix into the other ingredients, and therefore you end up with a final mix that contains some balls or chunks of the soaking phase that are very toxic to the cows. Phase 2, you then add first the mineral premix. There's no need to have the mineral premix to soak overnight, and then you load the fibrous feedstuffs that you have in the mix. And in a typical situation here, it would be grass silage. And you run the mixer during the loading of these ingredients, and then you continue mixing for 15 to 20 minutes under standard conditions. And then finally you will load the corn silage or other equivalent ingredient depending on your mix, and you will mix for another 15 to 20 minutes. It's not so that these are completely absolute. You will see that different farms with different conditions, they will change a bit on the mixing times and the relative amount of the phase 2 and phase 3, but try to keep the principle, and especially focus on providing enough mixing time in the phase 3 finishing phase here. Another thing to consider is the overall dry matter of the mix. So we will look both on the relative amount of dry ingredients and water, and try to keep that to have at least 1 part of water for 1 part of dry ingredient. But you also need to keep an eye on the dry matter of the total mix. So a typical situation with the vertical auger mixers, we will aim for 36% dry matter. With horizontal auger mixers, we aim for a little high dry matter, otherwise they will squeeze through too much water out of the mixer during the final mixing phase. Some farmers think that adding water is a problem, and of course, if you don't have the the right tools, it could be a little laborious. But there's several different solutions working in practice in Denmark. The best of them all is shown here as example one. That is a water tank underground, and then you have a remote controlled pump, and you simply just drive your mixer under this pipe, and then you press your remote control and you load exactly the amount of water you want, and you can do that no matter if it's summer or winter. Most other solutions, they have some problems during winter time. Another relatively popular solution is this water clock. So you just ask for the X and amount of tons of water that you need, and then you can leave your mixer. We also have see quite a few of different surface tank solutions, but of course both summer and low temperatures can be a challenge for these solutions. Another thing to remember is that when you really start to add water to your TMR, it's good to have an acid solution on stock for the very warm summer weather. So there's typically a few weeks during the summertime where you need to stabilize your TMR with acid. Another important thing to remember when you start to add water to a mixer is that it's a good idea to load the dry components with the mixer on hold to maximize the weighing precision. But as soon as you start to add the water, you need to run the mixer or run the augers in the mixer. Otherwise, the water will just find the nearest exit, and it's no good. So this example is just showing that we have filled here the commodities in the mixer, and then we simply run the mixer when we're adding the water. This next slide is really to warn you about the danger of adding too little water. It's a plot here showing a real life case. The situation is that the blue bars here are indicating the crude protein content of a TMR, and the blue is when we have sampled try to make a representative sample of the TMR, and the gray bars here are showing how we were able to select some of these soaking phase balls in the mix and see how different they are in composition from the average mix here. And the situation is that the silences for this mix were relatively dry, and the farmer was starting out adding quite a bit of water, but still insufficient amount of water in order to make this into a final TMR. So he started out adding 8 kilos of water per cow, and he ended up with a mix with about 43% dry matter. And you see what happened was that the mixer was actually making some of these balls of soaking phase and grass that are pretty toxic to the cows. And we see here that in this specific situation, we had to add 15 kilos of water per cow in order to enable the mixer to actually mix these ingredients into a homogeneous mix that didn't create this type of toxic soaking phase balls. So it's really important to remember that playing with water is no danger when you think about the risk of adding too much water, but it's really the real danger is if you add too little water. Another typical concern among farmers and also their consultants have been the potential overmixing of a TMR. So the fear has generally been that if you overmix the TMR and therefore destroy the physical structure, would that have negative impact on cows? I will say that we have done several research trials at the university where we have no indication of this of the potential overmixing with grass-based rations. And this slide is showing you some rations coming out of a more you can say practically oriented trial. But what we did was that we made a CompactTMR in a common mixer. So that's just mean that we use a little longer mixing time that you would typically see for a tractor pulled vertical auger. And we first, as we had two treatments, we had a, you can say, normal CompactTMR and an overmixed or an attempt to an overmixed CompactTMR. For the 1X TMR here, we soaked the commodities with water overnight. We loaded the grass silage and mixed for 20 minutes. Then we loaded the corn silage and mixed for another 45 minutes. So that's ended up with a quite decent CompactTMR. Then during the experiment, we would, after this step, unload half of the TMR from the mixer. And then with the other half of the mixed, we continued mixing for another 90 minutes. And we really got an amazing, nice mix after another 90 minutes of mixing. It was a mix that contained 30% of brass of dry matter. But after this very extensive mixing protocol, you could see absolutely nothing else but grass. The interesting thing is that when we were feeding cows with these two treatments, nothing happened in the barn. So no cow showed any signs of discomfort, displaced abomasum, loss of milk or anything. But the other also quite interesting thing is that the risk, or what some would claim would be the risk of having cows to overeat now that we have destroyed quite a bit of the physical structure of the mix, was also not seen in this study. So we had no indication that cows would overeat just before we had mixed, or just because we had mixed this ration so much harder. And the reason is probably that if this PMR or TMR was enough actually to sustain the cow with the nutrients they need, there's no drive on the cow to eat more. And that is another very interesting aspect about TMR mixing, because if you mix a TMR well, you prevent the cows from sorting. And when you are preventing the cows from sorting, they cannot select a ration that is different from your planned ration. And that is the typical problem with TMR feeding and late lactating cows, that the late lactating cows are having too little need for feed in order to produce milk, and they have too much time that they can use to sort, so they can stay at the feed bunk all day and sort out the starch of the TMR, and in that way they can sort them to a ration that is much better for fattening than the average TMR, and in that way you get over-conditioned late lactating cows in your herd. By feeding a CompactTMR, maybe this version is probably a little to overdo it, but just feeding in this version would actually prevent your cows from sorting out the starch that you feed. So you distribute your feed stuff according to your ration formulation, and not according to the time budget of your cows. So, but in general, except for adding the water, it's really important to add enough mixing time to your TMR. This video is showing a final mix in a Seco mixer. The typical recommendation is 15 to 20 minutes when you operate a vertical auger mixer, and opposite to what many believed in the past, you have to use a minimum of 20 minutes also in the horizontal auger mixers. So even though that the horizontal auger mixer tend to put a little more pressure on the TMR during mixing, it's very important to run them for enough time in order to actually mix everything up into a homogeneous feedstuff. One thing that is important to remember when we start to work with mixes with a higher density is to protect your tractor and your mixer um, from physical stress. Um, our recommendation is not to stop the mixer when you have started between loading and unloading. So when you have started the mixer in the morning after the soaking phase have been in the mixer overnight, you should not stop the mixer before you have unloaded. So during phase 2, phase 3, and unloading, you just keep the mixer running. That is minimizing the stress from restarting the mixer with a very heavy load. One thing that is often necessary in order to accomplish this is then to use a wide-angled PTO shaft because you would need to drive with the mixer running. Another thing to consider, especially in bigger mixers, is instead of the traditional gearbox to add a power shift gearbox, because then you can easily gear down the mixer when you have to move it. One thing you should consider when thinking about the physical demand on your mixer is that most mixers have been designed to a density of the mix of about 400 kilos per cubic meter. But when we are making CompactTMR, we might have mixes that are as heavy as 700 kilos per cubic meter. But definitely a common CompactTMR would be around 600 kilos per cubic meter. So quite a bit heavier than what the typical mixer have been designed for. One thing to also, when we talk about the mixers and another, you can say, potential negative impact of the CompactTMR with a more heavy mix is that the problem of carryover in some mixers can increase. This is not a problem for all mixers, but some mixers have a carryover problem. And that will especially be a problem when you first are mixing for the lactating cows and then try to make a small mix for the dry cows. Can also be a problem for the aerobic stability of the mix during the summer. But this problem is really very dependent on the auger design and the speed of the augers that you can have during the cleaning of the mixer during our unload. The restrictor plates on the mixers are to be used for cutting straw and not to be used when you mix a CompactTMR for your lactating cows. The restrictor plates, the function of the restrictor plates is of course to block some of the flow in the mixer so that you can cut the straw more effectively. But with the CompactTMR for the lactating cows, one of your biggest problems is actually to keep the flow in the mixer during mixing. So you should not use restrictor plates for the lactating cows. When you implement CompactTMR, it's really important to keep an eye on your feed mixer. And when you use CompactTMR, it's also really important to keep an eye on your feed mixer and make sure that you actually are doing the necessary maintenance. A fundamental problem that we have seen over and over again during the past years with CompactTMR is that many mixers in the field are unable to mix, especially during the phase 3. This video is showing an example of a mixer working on a structuring phase, a phase 2 mix, where we have added the corn silage. And you can see that the mix is totally frozen here. The auger is running, but the mix is not moving. It's especially important to keep an eye on the flow of the mix all along the side walls of the mixing chamber. A vertical auger mixer is working by the auger pushing up the mix in the middle, and then the passive return of the mix along the sides of the auger. And what typically happens is, as shown in this slide, that the auger is unable to clean the mixing chamber, and therefore the material start to build from the bottom of the mixer, and in that way it will block the function of the mixer. And this is a really serious problem. When this happens, you will end up, even though you will be running your mixer for 15, 20 minutes or 30 minutes, with something that has not been mixed up into a final feedstuff. This slide is showing different solutions to the problem from different makes of mixers. You see that it's all addressing this fundamental problem that the auger needs some help in order to clean the mixing chamber. Several companies they have factory solutions to cope with this, and for others the farmer is making their own. The real importance here is to keep an eye on it, and really to on a regular basis to monitor at least every time you change a silage, and hopefully also more frequently that you take a look at the flow in your mixer. It's important that, especially during the final phase, that you take a look, and that you see that it's like here. Every time you see that the auger is taking a turn, you will see that that fresh feed is removed from the sides of the mixing chamber, and fresh material is coming from the top and is rolling downhill here. And this movement and this disappearance of feed along the sides of the mixing chamber should take place all around the mixing chamber. There is no excuse for any parts of the mix being frozen during mixing. And if you observe that your mix is frozen, you need to take immediate action. It's not to be done next time you have service. You need to do something today. Another thing to remember is that there is a heavy workload on these devices that we add to help the mixer mixing. So this is showing an example that we see too often, is that it's kind of forgotten that we actually added this plate to the mixer, and 1.5 years later it's completely worn, and the function has been severely reduced. Also, the knives or the blades in the mixer, you need to keep an eye on them. Of course, different types of blades have different problems with how how they are affected by the time that they're working, and some of them are really giving off some nasty pieces of metal here. So keep an eye on your mixer, but the next you need to keep an eye on is your cows, because to observe the cows is a crucial part of keeping your CompactTMR on track here. So both the way the cows are eating and the way the cows behave in the barn are very essential indicators on how you're doing your mixing and your feed bunk management. This next slide is not really showing CompactTMR, but kind of showing the opposite. But it's simply just to illustrate the problems that we would like to solve by how we mix and how we feed. So in the past, I think this would be a more typical picture of a TMR. You see that the grass silage here is just in these chunks of grass. You see that there were added some straw here because of the fear of a lack of physical structure. You see that the corn silage is scattered loosely around the mix here. And as important or as serious is that if you kind of just remove some of this material from the feed bunk, you will see that under the mix you find the pellets and you find the commodities on the floor. And you will observe that as immediately when you feed a mix like this, your cows will eat like this cow here. They won't eat the mix from the top. They will eat it from underneath, and they will be cleaning the floor for all the small particles falling out of the mix all the time, and they will be standing for a long time at the feed bunk and be manipulating the mix to sort out the part of the mix that they prefer to eat. And this type of behavior often has a serious negative impact on the behavior of the whole herd. That you will see a situation like this, that just because you have been feeding your cows, they rush to the feed bunk, and some of the cows that might have the biggest need for feed are the early lactating cows or other weak cows, and there's not room for them at the feed bunk, so they will be prevented from eating. The other cows here that you think is standing here because they are eating, they are actually, of course, they are also eating, but what they're using most time for here is actually for sorting. And this behavior has a negative impact in terms of the time budget of the cow. So she shouldn't be standing here sorting. She should be resting in the pens. But another negative impact here is that they will be putting stress on the hoof by far too many hours of standing at the feed bunk. So what we really want to accomplish by a combination of feeding and also another important aspect of this, that is the amount of leftovers, is that we want to keep the cows away from the feed bunk. Not, of course, these cows have went for milking, but we see, and one of the other problems associated with feed bunk management here is that we have been feeding too little, and we have not been pushing up the feed. So this feed bunk is empty, even though we, in theory, has a significant amount of leftovers here. So it's important that you keep the feed within range of the cows, and it's really important that you feed enough so that the cow will never go to the feed bunk without having access to feed. So this picture is what we aim for, or it's shown here what we aim for. We aim for a situation where we have always plenty of feed at the feed bunk, so that the cows won't react to any feeding, or they won't react to any push up of feed, but simply no matter if you are running to the barn with a feed mixer or a front loader for pushing up feed, the cows, they simply just remain in the stalls. With a CompactTMR, the amount of time spent for eating or sorting at the feed bunk has been significantly reduced, and that is a true benefit, because it's here we want the cows to spend their time, not at the feed bunk. Many times we are asked how fast we should expect the cows to respond to changes in TMR quality. And this video is showing some cows that are presented for something like a CompactTMR for the very first time. You see, we still have too many cows coming to the feed bunk because they thought this would be a normal day. But you see how nicely they are actually eating on the top of this pile of feed, and you see some of the cows are really they kind of have to raise the head to swallow this big mouthful of TMR that they are taking in. So the point here is that you should expect the cows to respond immediately to TMR quality. But it's important to remember to keep an eye on how the cows are eating, because it might be that you can fool them for a few days by still not providing a perfect TMR. But after a while, they might figure out that you still have some imperfect conditions here, and therefore you should keep an eye on the cows and make sure that if they start to resume sorting behavior or any other odd behavior, you have to fix the problem. We have data indicating quite significant impact on TMR quality and feed allowance on the profile of how the cows are searching the feed bunk. The red triangles here are showing a situation with imperfectly mixed TMR and also a little too little leftovers. You see you have a lot of cows standing for a long time at the feed bunk, and the green squares here are indicating a situation where you have a more perfect TMR and sufficient feed allowance, and you see that the cows are kind of staying calm all day. So it's important to remember that your cows don't lie. And what you want to observe from your cows is that they are always eating from the top. They don't need the tongue for eating a TMR. An interesting consequence of a good mixing quality is that your mix will stay where you put it. Of course, the cow will remove it as they eat it, but they won't be moving around with the feed in the feed bunk. What we also like to see is that there's no reaction or a minimum reaction from the cows when you are feeding, and also when you are pushing up feed. And finally, when you remove the leftovers in the morning, take a look and make sure that the leftovers are identical to the mix that you are feeding, and if not, it's an imperfect mix that you are dealing with. In order to evaluate if we have implemented CompactTMR in a herd, I always say that we have at least these three criteria to evaluate before we can make any judgment. So we have to evaluate the feed mix to see if have we really been able to make the grass as this skeleton that is carrying all the other ingredients. Do we have moisture enough in the mix in order to keep the small particles inside this one and only feedstuff? The next thing is to evaluate on the behavior of the cows, because if they are not eating from the top and are not calm during feed out and push up, there is still something in the way you are feeding or mixing that is not perfect. And finally, have a frequent check on your feed mixer and make sure that you have sufficient flow in the feed mixer at all times. In this final section of the presentation, we will take a short look on production data and efficiency data from trials we have been running in Denmark, and also some of our national data. Starting in 2012 and 13, we did quite a few relatively small trials with 8 to 12 hertz, where we implemented the CompactTMR concept and were following these hertz for a month or two in a period of 1 or 2 months. So in general, we saw that there was a quite interesting positive response to the implementation of the CompactTMR. This slide is showing you that we have about 5% increase in milk production in these herds within a month. We have been following up on some of these herds where we now have data for a 2-year period, and you see on this slide you see the blue circles here are indicating a group of farms that we were working with in the beginning of 2013, where they implemented fully the CompactTMR concept. And for the next 2 years, they actually were feeding according to these principles. Um, and we have compared the milk production in those herds with a bigger reference group. Of course, one of our problems is that there have been a lot of awareness about CompactTMR, and many farmers have been implementing some of these principles partly or fully. So we believe that also in the reference group we do have some impact of the CompactTMR. But the interesting thing is still that this group of farms with with more dedicated to CompactTMR, they have a very strong development in their production. So in average, they were coming from a milk production of about 9,500 kilo energy corrected milk per cow back in 2012, and they now passed in the beginning of 2015 11,000 kilos on average, without any indications of negative impact on health of their cows. On the contrary, indications were positive. On a national level, we have also seen a quite interesting increase in milk production. This slide is showing the average on the production by all Danish Holstein cows. I cannot claim that this is just due to CompactTMR, but at least the implementation of CompactTMR starting in the beginning of 2013 in more general have not prevented or has not prevented the Holstein cows in this country from putting on quite a bit amount of milk. And another, especially for this seminar, important aspect of the overall effect of CompactTMR is shown here, because in all the trials we have been doing, we have had indications on increased feed efficiency all the way through. Of course, these data are not that strong, and so it's hard to get data that is strong enough to really show significant differences between treatments. But all the indications we have from the different trials is that we have accomplished an increased milk production with increased feed efficiency by implementing the CompactTMR principles. And after this, and you can say that's a relatively, in my view, positive story. I still think that we have another positive aspect of the CompactTMR principle, and that is the ability to connect a surveillance program on feeding with production result from the herds and the overall analysis. Because with the CompactTMR, we expect to have a very good relationship or association of between the composition of the ration we are feeding, the composition of the ration that we are planning, with the ration that the cows are actually eating. So by sampling the CompactTMR in the barn, we have actually sampled what the cows in this barn is eating. So by analyzing the sample, we are analyzing what they are eating, and therefore we have a much better starting point for analyzing the associations between chemical and nutritional composition of rations and production response by dairy cows. So with this, I would like to thank you for attending this seminar, and we will we will keep the chat open for another 30 minutes or more, depending on the activity. Thank you very much for your attention.